Then we fill in the multiples of 30 degrees. So we want to go from 0, 30, 60, 90, 120, 150, 180, all the way around. Of course, not repeating the ones we actually already know. And to do that, we're going to use 30, 60, 90 triangle, which had its own formulas for the lengths of sides. If you remember, across from the 30-degree angle, that was the n, and the hypotenuse was 2n. So the hypotenuse is double the shortest side. N, 2n. If you might have used x, 2x, I just don't want to confuse it with the coordinates that we're going to use on the next slide or on future problems, so I'll just use n. Right? And then whatever the long leg across from 60 degrees is whatever that short side is times the square root of 3. So let's see. We know when we place this on the unit circle, the hypotenuse is going to be the radius, and that's going to be 1. So using that as the starting point, I can solve for n, right? N equals 1/2. And then n times the square root of 3 will be 1/2 times the square root of 3. But that will always be written as root 3 over 2. Right? There shouldn't be any confusion that those are the same thing. Right there. Yeah. Okay, so again, this is just kind of motivating where did these coordinates come from? Because we use them over and over again in the unit circle. And they come from things that you've done before, right? The special right triangles. So in our circle, like if I take the triangle that I just had and I moved it in, it would be right here. Right? There's the 30-degree angle. There's the 60-degree angle. We just said if the radius is 1, then the length of this side is the square root of 3 over 2. And the length of this side was the 1/2. Now if I go to 60 degrees, I mean, it's still the 30, 60, 90 triangle with a hypotenuse equal to 1 because the radius equals 1. What changed now is it's actually the short side now is the x-coordinate, 1/2, and the long side is the y-coordinate, root 3 over 2. So that's how you go from 30 degrees to 60 degrees. It just switches the coordinates. And you know, if I go like this point, so if I go over to this angle here, then what's changed? The only thing is that now we're going in a negative x direction. So the 1/2 becomes a negative 1/2. It's still positive root 3 over 2 for the y because it's above the middle positive direction. If I relate this point across the circle to this point, then again the x coordinate's got to be negative because you're in quadrant 2. X is negative in the second quadrant. Y is still positive. So you can see how we spread this root 3 over 2 comma 1/2 in some order to all of these points on the circle. The only thing changes is the order, and sometimes they're positive and sometimes they're negative. Now, the 30 degrees is pi over 6 radians. How could you confirm that it equals pi over 6 radians? Or convert it to radians, right? Multiply by pi over 180. It's pi over 6. So every 30 degrees is pi over 6 radians. So again, you can count it like this, right? You start, this is 0. This is 1 pi over 6. 2 pi over 6, but 2 pi over 6 is pi over 3. Right? 2 over 6 is 1/3. 3 pi over 6, 4 pi over 6, which is 2/3. 5 pi over 6, 6 pi over 6, 7 pi over 6. You know, just keep counting the pi's over 6 going all the way around. There's 12 of them. Some of them reduce as fractions to thirds or halves. Okay. So that's now you should have at this point filled in all of your angles and all of your coordinates for what we call the unit circle.